Hello, PreCalc. This is the PreCalc Edgenuity Section 8.3 called Equations of Hyperbolas. Three objectives to this section. First, to determine the foci, directrices, vertices, and asymptotes of a hyperbola with center at the origin from an equation or graph. Next, we want to be able to graph a hyperbola with center at the origin from a given equation. And last, we want to be able to write the equation of a hyperbola with center at the origin from a given graph or information about its foci, directrices, or vertices. So let's look at our first problem. We've got a little sketch here of a hyperbola. Hyperbolas have this shape right here, and you'll see that this shape can either be side and side like it is now, or it can be up and down. So this one happens to be side to side, and our general equation, our standard equation, not our general, but our standard equation for a hyperbola looks either like this: x minus h squared over a squared minus y minus k squared, squared like that, over b squared equals 1. And that actually gives us the type of hyperbola that we're looking at now, that shape right there. The other option is that we start with y minus k all squared over a squared minus x minus h all squared over b squared, and it still equals 1, but then we get the shape where the curves are up and down. Okay, so that's the difference between the two. And so we know from looking at this that we're going to be using this version of that in this one. So for the moment, we're going to ignore that one until we need it. And the other thing we want to note is that for these hyperbolas, the center is always at HK, just like circles, just like all the other conic sections. All the conic sections, their centers are always at HK. Okay, ellipses, all of them. So in this case, the center is right there. So in this case, our HK is 0, 0, the origin, right? Which is going to be the case throughout this particular section, and then we'll look at ones beyond that. So what we get is we wind up putting a 0 there and a 0 there. So we're going to have x minus 0 squared over a squared minus y minus 0 squared over b squared equals 1. And then we got to know about this a squared and b squared. Okay? And the way that works is the a distance is from the center out to a vertex, the vertex being the turning point of each parabola. So there's an A distance there, there's an A distance there. And then there's a B distance, and the B distance is based on this rectangle that you see here. And what the B distance is it's from the center out to that to the end of that rectangle 90 degrees away from the vertices. Okay? And what this rectangle is it gives you a way to create asymptotes through the center that the curves follow. And this is how we are able to draw the hyperbolas. So I should, since it's at the origin, A and B are pretty easy to figure out. So A is a distance of 5 from the center. It's always the distance from the center. And B, you might see, is a distance of 12. So what I'm going to do is I'm going to clean these two up. And I'm going to say that's x squared over A squared, which is now 5 squared, so that's 25. X squared, because x minus 0 is just x, and then the squared coming from there. Okay? Minus, likewise, y minus 0 is just y, and then squared, over b squared. B is 12, so b squared is 12 squared, which is 144, equals 1. And there we have the equation of the hyperbola. All right. I'll let you look at that for a second. And let's move on. Let's talk about writing the equation of the graph for this one. Now we've got the curves going up and down. So this case is the y minus k all squared over a squared minus x minus h all squared over b squared equals 1. In general, whatever direction the curves are going, if they're going in the y direction, the y starts it and the a is underneath that. If they're going the other way, the x starts it and the a is underneath that. Okay? Again, we've got our center at the origin, so our center, I'll keep writing this, is at 0, 0. And remember, our center is always our HK. You have to be careful in this format that you don't mix up H and K. H is still over here, K is still over there. Okay? So this gives me y minus 0 all squared over a squared. Now a is there and the b distance is there. I gotta let things catch up for a second. So a is there and the b distance is there, and that's because to go from the center to the vertex of the curve, that's how we have to, that's always the a distance, okay? So that's why the a is underneath the y part this time. All right, so then what is a? A, as you can probably see, is 15. What is b? B, you can probably see, is 8. And so 15 squared, that's 15 times 15, that turns out to be 225. Actually, let me let me show the details of it. That's 15 squared. So that's that 15 right there. Minus x minus 0 squared over b squared, and b is 8, so that's over 8 squared equals 1. And then we'll clean this up, simplify everything that we can. Y minus 0 is just y, so that's y squared over 15 squared, which is 15 times 15, which is 225. Minus x minus 0 squared, which is just x squared, over 8 squared, which is 8 times 8, which is 64, equals 1. And there we have the equation of this hyperbola. I'll give you a moment, let you look at that. And then we'll move on. So now we've got a description. Instead of starting with a graph, now we're going to start with a description. Okay? Now, this time we've got a hyperbola with its center at the origin, a vertex at 9, 0, and a focus at 41, 0. Has what equation? So we want to write the equation for this. The first thing I would do is draw it. Okay, let's draw a little one. We're going to need a lot of x space. Let's say 9, and say -9 is right there. We know the center is at the origin. It's at 0, 0. That's what the origin means, 0, 0. And then we've got this thing called a focus point. And it's way out here at 41, 0. Now, the focus point is really interesting. You'll see it talked about a lot in the lesson. So I'm not going to go over it a ton. However, the focus point is extremely important and really, really cool. Okay? So we've got vertices there and there, and I'm just gonna like draw some version that fits more than anything else. This is not necessarily accurate. Okay, somewhere out here we have another focus point at -41, 0. And then somewhere like up here and down here somewhere, we have these points that help us create the rectangle that we need. And as you can see, I have not drawn this very well because the asymptotes wouldn't fit the curves and stuff like that. The asymptotes would be going like that and like that, but I'm just sketching it out here to remind myself of some stuff. Okay, so the important part is this. Okay, let me use a different color here. Let me use red. This distance is the distance A. That distance is the distance B. And then we have a third distance. And that third distance is from the center out to the focus point, and that is a distance C. And similar to ellipses, there is a Pythagorean theorem right triangle relationship between A, B, and C, and this time you can see that if I just draw a hypotenuse connecting the ends of the A distance and the B distance, I get a right triangle, and it is true that the distance of that hypotenuse is C. So from that, we can see that in hyperbolas, A squared plus B squared equals C squared. Now remember, that wasn't quite the same for ellipses, but that is how this works for hyperbolas, and you just got to be able to construct the right triangle, and you should be able to see which relationship holds. The longer side is always going to be the hypotenuse, of course. The longest distance is always going to be the hypotenuse. So, so now we have this, and I know a few things. I know A. A is 9. I can tell that from a vertex point. I don't know B, but I do know C. C is 41. Okay? And so I can use Pythagorean theorem to solve. This would be 81 plus B squared equals 41 squared. I'm going to use a calculator to figure out what 41 squared is, because it's a big number, and I could do it on paper, I suppose, but okay, 1681. Oops, 1681. Well, that's going to be super convenient, because then as I solve, I'm going to subtract 81 on both sides. I'm going to get B squared equals 1600. And so when I take the square root and the positive square root, I'm only taking the positive square root because we're talking in distance. Then that distance B is 40. Okay? You can figure that out if you want. Split 1600 into 16 times 100, and then the square root of 16 is 4, and the square root of 100 is 10, and 4 times 10 is 40. So now I have B. Really, though, what I needed was B squared, right? Because, okay, so it's in the x direction. It opens in the x direction. So we know we're going to have the x minus h squared over a squared. Oh, whoops, not plus, minus y minus k squared over b squared equals 1. Our center is at the origin, so we're at 0, 0 there, so it's x minus 0 squared over a squared. A is 9, so 9 squared is 81, minus y minus 0 squared over b squared, which is 1600 from my calculations. That equals 1, and then finally I can clean up the top and have a final answer of x squared over 81 minus y squared over 1600 equals 1. I'll pause for a second, give you a chance to look at that. And let's move on. So now, let's talk about the other way. If I give you the equation, let's talk about graphing it. So here we have an equation for a graph of a hyperbola. How can I tell? Well, a few things. I've got y squared, and I've got x squared. I've got a minus between them, and it equals 1. That's the basic way I can tell that it's a hyperbola. Notice that it's just y squared. Notice that y comes first. So since y comes first, it's got to do something like that. Again, this is like super rough sketch. That's not my graph yet. That's just super rough sketch. Okay, that's just so I know how it opens. Opens in the y direction because the y comes first. What that also means is that 4 there is a squared. Meaning, if I take the square root on both sides of that, my a is 2, right? So then this must be b squared, so 16 equals b squared, meaning that my b is 4. So those two things are incredibly important. Also, I got to think about what is my HK, my center. Well, if you think of y as y minus 0, and let's put it over 2 squared, we'll call it 2 squared instead of 4, minus the x minus 0 is the same thing as x squared over 4 squared equals 1, then we've really got the information that we need. So here's my h right there. Here's my k right there. Oops. K is 0 there. And now I have all the information I need for this, right? I should be able to give a pretty good sketch of this. So let's take a look. So my A distance, first of all, my center is at 0, 0. So there's my center right there. And let me make some marks here. My A distance, which is in the y direction, is at 2, and that's in each direction from the center, so up 2 and down 2. And then my B, which is in the x direction, is a distance of 4, like that. And then let me use a different color. Use green, and I'll draw the box. Okay, so there's the box. My vertices happen in the y direction. That is, the vertices happen an A distance away in the direction that the A is underneath. Okay. Let's draw our asymptotes. So the asymptotes go through the center and the corner of this box. Okay. And now that I have all of that information, and I know generally what it looks like, I can start at a vertex and follow the asymptotes and get a much more accurate picture of what that hyperbola looks like now. I'll let you look at that for a moment. All right, let's move on. All right, now we've got another description. Hyperbola centered at the origin. Okay, so we're centered at the origin again. Has a vertex at 3, 0, and a focus at 9, 0. What are the equations of the directrices? And a reminder, the directrices work the same way in a hyperbola as they do in an ellipse. The distance of those lines from the center to where they are is equal to the a squared over the C distance, the A distance squared over the C distance. So I always like to draw these out and see what I'm looking at. So, okay, I got a vertex at 3, 0, a focus at 4, 5, 6, 7, 8, 9, 0. So this is a vertex, this is a focus, which means there's going to be one over here, and there's going to be a focus point way over here. And so it'll open in the X direction, like that, with the center at the origin. Again, that's a really rough sketch. I don't know that it really looks like that. I'm just giving a rough sketch here, okay? I do know some things, though. I know my A distance is 3. I know also that my C distance, that is the distance from the center to my focus, to one of my focus points, is 9, right? Because we've got 3 here, 9 here, center at the origin. So it's pretty easy to count that. That means I can calculate my directrix distance as A squared, which is 3 squared, over C, which is 9. That's 9 over 9, which is 1. Okay? And then you have to know how the directrices move. Well, they move so that they wouldn't run into the vertex. In other words, it's a distance of 1 away, so let me put the directrices in red, because I don't really like them anyways. They're kind of evil. 1 is here, 1 is here, each a distance of 1 away in both directions, and traveling so that they never touch the graph itself. So they're sort of, you could look at, it opens in the X direction, but it moves up and down. That is, this is moving up, this is moving down. So we want this to move up and down also. And then for the equations, vertical lines means we have X equations, right? So directrix 1, directrix 2 will each have an X equals, and one of them will be X equals 1, right? It's every point along this particular red line here has an X value of 1, and then the Y values change as you move up and down, but the X value never changes. The X value is always 1, so all I need is X equals 1 to describe that line. Similarly, the directrix equation for directrix 2 is X equals -1, and so there we have that. All right, I'll let you look at that for a moment. And then we can move on. Let's talk then a hyperbola with center 0, 0, that is at the origin, and a focus point of 0, 5 with a directrix with an equation of y equals 9/5 has what equation? So let's sketch this out again, and I've again reminded you of how the directrix is calculated here. So center at 0, 0, a focus point at 0, 5. Let's just put that there. And so let me put another focus point there. And that's the focus point, so the curves are going to be inside of that somewhere. And then y equals, let me put the directrix line in at y equals 9/5. We'll just sort of pretend that that's y equals 9/5, and then y equals negative 9/5 would have to be the other one. And because we're at the origin, we know that that d distance is also 9/5. Okay? We also know the c distance. The c distance is told to us right there. So 9/5, the d distance, is equal to a squared over the c distance, which is 5. Okay. Now, I know you look at that and you go, oh, I know how to do that. I can look at that and almost divine the answer from that. I'm going to do the math just to be sure. We're dividing by 5, so to get rid of that 5, that is to have the a squared by itself, I need to multiply by 5. Then I'm forced to multiply by 5 over here. That'll cancel them. That is 5 divided by 5 is 1. And then 5 divided by 5 is 1, so these cancel also, and I get 9 equals a squared, and then I do square root, positive square root because we're talking distance here, and so that a distance is 3, although you could argue that knowing the a squared value is more important here. So then we know where our vertices are, and then we need, let me draw the box in green, then we need the value of the box. In particular, we need to know the distance from there to there, because we've got the a distance there, so we got to know the b distance there, and then this will be the c distance, but we already know that the c distance is 5, right? And actually, we already know what the a distance is. That's 3. A distance is 3. So, looking at it, we can tell that that means a squared plus b squared equals c squared. And we know a squared is 9. We don't know b squared. We know c is 5, so c squared is 25. If we subtract 9 on both sides, we'll get that b squared is 16. And I don't even have to calculate b, because I'm trying to find the equation, and the equation is over a squared and over b squared, right? So it's in the y direction, so the setup for this is y minus k squared over a squared minus x minus h squared over b squared equals 1. And then my h and my k are 0, so y minus 0 is just y squared, over a squared, which is right there. A squared is 9, minus x minus 0 all squared is x squared, over b squared, and b squared is 16, equals 1. And there I have the equation of the hyperbola. We're going to stop here, and that is the end of this particular section. Thank you, everybody.